So today we are looking at classification of substances. Classification of substances. And now we are defining a substances as substances. So we are saying that substances are either pure or impure. So we are saying a pure substance is one which contains only one kind of matter. Is one which contains only one kind of matter. Remember, we say that we have three kinds of states of matter. One contain one kind of matter, or one state of matter. I remember we said we have three states of matter. We have solid, liquid, and gas. So a pure substance is one that can either be only liquid or only solid or only gas. So that's one we can term it as a pure substance. Then an impure substance is one which contains two or more kinds of matter. It's one that contains two or more kinds of matter. So a pure substance is made up of a pure solid, pure liquid, or pure gas. So of one of the three states of matter, when a substance has one of the three states of matter, it will term it to be pure. And when now the substance is made up of more than one, it's made up of more than one, two or more, so we'll say it is impure. We'll say it is impure. So a mixture is a combination of two or more. s- more m- a mixture is a combination of two or more pure substances. Remember, before these substances are mixed, earlier before, they were on their own. Each substances was on its own. If, for example, if we mix solid and liquid, remember before mixing process, for example, we are mixing sugar and water. Before we had water as a pure substance, and also sugar as a pure substance. Then after now mixing them, they become a mixture, which will say that they are now impure because now they are mixed. So that's why we are saying a mixture is a combination of two or more pure substances which can be separated by physical means. Which can be separated by physical means. Now, a mixture, what makes now here a mixture can be is a combination of two or more substances, but now they can be separated by physical means. So a mixture is a combination of two or more pure substances which can be separated by physical means. So remember, when we are combining a mixture, when we are combining either solid and liquid or gas, or solid and another solid, remember, we are combining them to form a mixture, where in this mixture they retain their physical and chemical properties. They just retain them. Then on separation, we'll use physical means. So the three states of matter in nature appear mainly as mixtures of one with the other. Appear mainly as mixtures of one with the other. Now we have the common mixtures that we have. They include solutions. So solutions are made from liquid and solid mixture. So the solid is dissolved in a liquid to form mixture. So those ones are solutions. So let's have we want to look at an experiment on how we can form now a solution. How we can form a solution of a solid being dissolved in a liquid. So the experiment is to make a solution of copper 2 sulfate. So, or we can make a solution of potassium manganate 7 or sodium chloride. So we can use any of these to make a solution, either copper 2 sulfate, that is blue in color, potassium manganate 7, that is purple, and then sodium chloride, that is white. Remember, we say that in a mixture, the Combining substances attain their physical and chemical properties. So the procedures that we have to make it, we put about 100 centimeter cubed of water in 3 separate beakers. So now we are carrying out all the experiment using all the three using all the three solids now. So we are saying we put about 100 centimeter cubed of water in three different or separate beakers. Then we separately place a half spatula end full of copper 2 sulfate, potassium manganate 7, and sodium chloride crystal to each beaker. Remember, we have first put water in the beakers, three separate beakers. Now, then in each and every beaker, we are placing a different solid. The first one we have copper 2 sulfate. The second one we have potassium manganate 7. Then the third one we are having sodium chloride crystals. Then we stir for about 2 minutes. The reason as to why we are steering is to help us so that this uh, so that the solid can dissolve somehow at a higher rate compared to when we just leave it. It will take more time compared when we are steering. So on steering, we are now trying to make it dissolve faster as compared to when it's just left to dissolve on its own. So as earlier we said that in chemistry, remember in the first topic we say that chemistry deals with experiment. So we carry out experiment, we make observation, we analyze, then we analyze our observation, we have explanations about what we have observed, then finally we make conclusion. So after carrying out the experiment, we have the procedure to carry out the experiment. Now we want to observe what happens. So copper 2 sulfate crystal dissolved to form a blue solution. Copper 2 sulfate crystals dissolved to form a blue solution. Now, what makes the solution be blue is because of the color of the copper 2 sulfate crystals. Copper 2 sulfate crystals. Then potassium manganate 7 crystal dissolved to form a purple solution. A purple solution. Then sodium chloride crystal dissolved to form a colorless solution. Remember we say that we are using these crystals, we are steering these crystals so that we come up with a solution. So then after having observed that, so then we have now to explain. So now the explanation. Some solids, liquids and gases dissolve in some other liquids. So not all solids will dissolve in all liquids. So that's why you're saying that some solids, liquids and gases dissolve in some other liquid. So a substance or a liquid in which another substance is dissolved is called a solvent. So in our case here, our solvent is water. Our solvent is water. So the water we are using here is which the other substance, the solids that we are having. So in this case we have copper 2 sulfate, potassium manganate 7, and sodium chloride are the substances that are dissolving in our solvent, in this case which is water. So a substance or a solid or a gas which dissolves in a solvent is called a solute. Now the solids that we had in this case, which are copper 2 sulfate, potassium manganate 7, and sodium chloride, we are calling them solute. So now we have solvent as water, solute as copper 2 sulfate, potassium manganate 7, sodium chloride. Now we are forming the solution. When a solid dissolves in a solvent, it forms a uniform mixture called solution. So, after dissolving our solute in the solvent, we are now forming a solution. We are now forming a solution. we are now forming a solution. So a solute dissolved in water as the solvent exists in another state of matter called aqueous. So after having dissolved the solute that we have in water as the solvent, so now the solution is in another state of matter which we are calling aqueous. So water is referred as the universal solvent because it dissolves many solids. So for the case of water, water dissolves many of the what many of the solutes. So we are saying that water is a universal solvent. Water is a universal solvent. So that we are saying water is a universal solvent. Reason being that it dissolves many of many solids. It dissolves many solids. Water is referred as the universal solvent because it dissolves many solids. A solute that dissolves in a solvent, a solute that dissolves in a solvent. So we are saying that a solute that dissolves in a solvent is said to be soluble. Is said to be soluble. So our solutes are soluble because they dissolved in the solvent, which is water. So soluble particles uniformly spread between the particles of water, which is the solvent, or we have many solvents and cannot be seen. So when the particles of the solid cannot be seen, that's when we say that the solute is soluble. That's when we say that the solute is soluble. So the solute becomes soluble when the solute becomes soluble when the solute becomes soluble when the particles of the solute are able to dissolve in the solvent and cannot be seen and cannot be seen. So that's when you say that it is soluble. So we are saying that a solute added to a solvent, it makes a solution. So solute plus water, we have an aqueous solution of the solute. Have the aqueous solution of the solute. The solute dissolved in water gives the name of the solution. So for example, in our first case, we had sodium chloride solution. So it's a solution formed. Sodium chloride solution is a solution formed after dissolving sodium chloride in water. After dissolving sodium chloride in water, then in water, sodium chloride now exists in aqueous state after dissolving. So now we don't have the solid sodium chloride that we had earlier, but in this case now it is in aqueous state. It's not now in solid state, but in aqueous state because it has been dissolved in the water. So we have a word equation: sodium chloride added to water, you have sodium chloride solution. Then you have the chemical equation. Now we have that's the word equation. This is the chemical equation. You have sodium chloride, which is solid. So Na is a chemical symbol for sodium. Then Cl is a chemical symbol for chlorine. Then you have H2O for water. Then S is a state, the state of the matter, which is solid. L is state of the matter of water, which is liquid. Then AQ is state of matter for aqueous. So that's we'll cover it as we go on. So ammonia solution is a solution formed after dissolving ammonia gas in water. So ammonia exists as aqueous state after being dissolved in water. So ammonia dissolved in water, you have aqueous ammonia. Copper 2 sulfate solution is a solution formed after dissolving copper 2 sulfate crystals in water. Copper 2 sulfate crystals or solid in water. So copper 2 sulfate exists in aqueous state after dissolving in the solvent we have as water. So copper 2 sulfate being dissolved in water will have copper 2 sulfate solution. So we say that the solute will, when we are dissolving the solute in a solvent, now the solute will have as the solute solution. That's why now we have copper 2 sulfate solution. Have potassium manganate 7 solution formed after dissolving potassium manganate 7 crystals or solid in water. So still it's just be the same. Potassium manganate dissolved in water, the word equation, then the chemical equation. And now the second thing we want to look at is suspension. Remember we have looked at the solution. For the solution one, dissolving the solid in a liquid to form a solution. Or you say that the liquid now is a solvent, the solid is a solute. Now what we are forming a solution, and the solution we call it depending on the solute used. Now the solute solution is what we are forming. So suspension, also we call it a precipitate, which will be a solid liquid mixture which do not dissolve. Remember, the first one is a solid liquid mixture in which the solid dissolves in the liquid. And for the second case is a precipitate or suspension, where the solid does not the entire of the solid crystals or particles will be able to dissolve in the given liquid or in the given solvent. Now, this is the experiment that we are carrying out. Then we'll make some observations, explanations, then we come up with conclusions. So you want to make soil flour, lead 2, iodide, precipitate or suspension. So those are two experiments that we want to carry out. Those are two. In fact, they are not two, they are three. We have soil, we have flour, and then lead 2 iodide. So those are three experiments that we are carrying out to see the formation of suspension or precipitate being formed. So we put about 100 centimeter cubed of water in 3 different or separate beakers. Then we separately place a half spatula end full of, in the first beaker soil, we have maize flour. Then we have lead 2 iodide beaker. We have lead 2 iodide in the third beaker. Then we stir about for 2 minutes. So we say that we are in stirring, we are now speeding up the dissolving process so that it does not take too much time. Now, what are we observing? So we observe that some soil, maize flour, some soil, maize flour, and lead 2 iodide float in the water. Some float. So a brown suspension or precipitate or particles suspended in water containing soil. So there are some particles that we'll see on top of that beaker containing soil, and water. A white suspension or precipitate or particle suspended in water containing flour. It's also seen a yellow suspension. Then now we have under yellow suspension and yellow suspension or precipitate or particle suspended in water containing lead 2 oxide, lead 2 iodide, lead 2 iodide. So some soil, maize flour, and lead 2 iodide settle at the bottom after some time. It will not just settle immediately, but it will settle after some time after you have stirred. So then let's now explain this phenomenon. Some solid substances do not dissolve in a liquid, so they are said to be insoluble. So remember, in the first case, we say those that dissolve, we say that they are soluble. So those that do not dissolve, we say they are insoluble. Insoluble in the solvent. When an insoluble solid is put in a liquid, the following happens. 1. Some particles remain suspended or floating in liquid to form a suspension. So we have some that will be floating to form a suspension or a precipitate. Some particles sink or settle to the bottom to form sediments after being allowed to stand. That's why you say that the settling of some particles at the bottom happens after some time. So after stirring, we allow it to settle for some time. Then we'll see that some particles are now forming at the bottom, and then we have some particles are floating. So the one floating are the one that are forming the suspension. So an insoluble solid acquires the color of the suspension or the precipitate. So for example, in our case, we had soil, so we have a precipitate of soil. We have maize flour, we have a precipitate of maize flour. Then you have lead 2 iodide, we have a precipitate of lead 2 iodide. So a white suspension, precipitate, have some fine white particles suspended or floating in the liquid. So we cannot call it to be a white solution because not the entire of the particles of the solute has been able to dissolve. So we cannot call it a white solution. We just call a white suspension or a white precipitate. So it is either a blue precipitate, not a blue solution. A green precipitate, not a green solution, because we have some of the particles that have settled at the bottom. Then you have some that are floating on the top. So that's what makes us not to call it a solution, but now a solution, but now not a solution, but now a suspension or a precipitate, because we have some particles that are now being formed at the bottom, and others are now floating. Then let's look at liquid mixtures. So first we have looked at the solid liquid mixtures, that are soluble. Second, we have looked at the solid liquid mixtures that are insoluble. So we say that for the soluble, they'll form a solution, and the solute will form a solid solution, and then the second one that are insoluble they'll form a suspension or a precipitate. So let's look at miscible liquid mixtures. So to form water, ethanol, kerosene, turpentine, miscible. So miscible. When we say they are miscible, we are saying now they are able to mix completely. They are able to mix completely, so that we only see one layer. We only see one layer of the two liquids that have been mixed. So that's why we call them miscible liquids. That's why we call them miscible liquids, because they have been in a position to mix. So the procedure, we measure about 50 centimeter cubic of ethanol into 100 centimeter cubic beaker. Then again we measure 50 of water. Then we place into the beaker containing ethanol. Then we swirl for about 1 minute. So swirling helps for them to mix. Swirling will help for them to mix. So the reason that's why we are using 100 cubic centimeter beaker is because now we are having half of each. You have 50 of water, then you have 50 of ethanol. Have 50 of water, then 50 of ethanol. Then we swirl. Swirling aids helps for them to mix. Swirling helps them to mix. So we measure. Then experiment 2, we measure 50 centimeter cubic of kerosene. Also, we are putting it in 100 centimeter cubic beaker. Then we measure also about 50 of turpentine oil. We place the turpentine oil into the beaker containing kerosene. Then again, we also swirl for about 1 minute. So this is an experiment that now we are carrying out. Remember, we measured water 50 centimeter cubic, kerosene. For the first reaction, for the first experiment, 50 centimeter cubic of water, 50 centimeter cubic of ethanol. Then now we place them in one beaker. For the second experiment, 50 centimeter cubic of kerosene and a 50 centimeter cubic of turpentine oil. We also place them into one beaker. And then in each and every experiment we are swirling so that we allow them to mix. Now let's see let's look at the observation. So the two liquids do not form layers. So ethanol and water form a uniform mixture. So they form a uniform mixture. So we are saying that they mix completely to form a uniform mixture. Only to form one layer. Only one layer is formed. Kerosene and turpentine oil also form a uniform mixture. So ethanol is miscible in water, and all same applies to kerosene, that is also miscible in turpentine oil. So miscible mixture form miscible mixture, or miscible liquids form uniform mixture. So miscible liquids form uniform mixture. They do not form layers. So the particles of one liquid are smaller than the particles of the other. So the smaller particles occupy the spaces between the bigger particles. So that's why you are saying that they form a uniform mixture. So let's look at now immiscible. So immiscible is just the opposite of the miscible ones. Now in this case, they do not mix. There is a formation of a two layer. We realize that there we have two layers. We'll have two layers of this liquid. We'll have two layers of these liquids. So for the immiscible ones, we have two layers of these liquids that are being formed. that are being formed. So for the case of immiscible, they will not be in a position they'll not be in a position to form a uniform layer. They'll not be in a position to form a uniform layer. So we still just have the same liquids that we used for the miscible one. So to form water and turpentine oil, then kerosene and water. Immiscibles, not now miscible, immiscible. In this case, now we have immiscibles. So now we have the procedure. Now we have the procedure for the experiment that we want to carry out. So again, we'll just measure 50 centimeter cubic of water into 100 centimeter cubic of the beaker. Then we measure again 50 of the turpentine oil. Place the oil in the beaker containing water. Then we swirl for about 1 minute. Then experiment. Then we let it settle. Then again we measure 50 of water into 100 centimeter cubic beaker. We measure 50 centimeter cubic of kerosene. Again, we place them in one beaker. We swirl and we let them settle. After letting them to settle, we have the observations here. So two liquids form layers. In the two experiments, all the liquids will form layers. So turpentine and water do not form a uniform mixture. Same applies to water and kerosene, do not form uniform mixture. So let's have an explanation of this. So kerosene is immiscible in water. When you accidentally pour water in a kerosene container, you will see that you have two layers. So they are immiscible. Same applies to water with turpentine oil. So immiscible liquids do not mix. So immiscible liquids do not form uniform mixtures. They form layers. So the size of the particles of one liquid is almost equal to the size. Now remember, in the miscible case, we say that one of the liquid has particles that are smaller compared to the other one. Now the spacing between the bigger particles of the other liquid is now covered. It's now covered by the smaller particles. Now the smaller particles go and occupy the larger the spaces in between the larger particles to form a uniform mixture. Now, for the case of the miscible ones, we'll find that these liquids, they have particles that are almost equal in size. Now, now the particles cannot occupy the spacing between the particles of the other liquid, which leads them to form two layers. Each liquid will have to occupy its own space. So the heavier one will be at the bottom, and then the one that is slightly light will be at the top. So the particle of one liquid can occupy the space between the particles of the other. So the heavier particles settle at the bottom, the less dense particles settle on the top. That's what makes us to have two layers. Then now let's look at solid mixtures. Now these are types of mixtures. Remember, we started with solid liquid. The first one was soluble, the second one was insoluble, then liquid mixtures. We had the miscible and the immiscible. Now we are looking at solid mixtures, or we can also call them alloy. So before solidifying, some heated molten or liquid metals metal liquid, heated molten or liquid metals dissolve in one another metal to form a uniform mixture of the two. And on solidifying, a uniform mixture of the metal is formed. So a uniform mixture of the two metals solidifying is called an alloy. So we are saying that we can heat a solid to form a molten metal or a liquid metal, and after having heated them, they will dissolve in one another to form a uniform mixture of the two. Now then, on solidifying, a uniform mixture of the metal is formed. So we are saying that a uniform mixture of the two metals on solidifying is called an alloy. So in the alloy, one metallic particle occupies the space between the metallic particle of the other. Now let's look at the common alloys of metals. Have the name of the alloy, the constituents of the alloy, then the uses of the alloy. So we have the first alloy as brass. So brass is composed of copper and zinc. So copper and zinc, they'll form an alloy called brass, and they are used in making screws and bulb caps. So you have the second alloy being bronze. It is a composition of copper and tin. They are used in making clock springs, electrical contacts, and copper coins. So you have the solder. So the solder is made up of lead and tin. The function is used in soldering. So soldering is joining electrical contacts because of its low melting points and high thermal conductivity. Now, soldering is used mostly in electrical, used by mostly electrical people. So if they want to join electrical contacts, so they use a solder. So then another one we have apart from that solder, we have duralumin. Duralumin is made up of aluminium, copper, and magnesium. So it is used in making aircraft utensils and window frames because of its lightweight. Now, this alloy is used in making the aircraft because of its lightweight. You have also utensils, you have window frames. So reason as to why it is used in them, because of its lightweight and corrosion resistant. Now, it is resistant to corrosion. So those are the some of the alloys that are made from the melting of those metals to form the mixture. So another one we have steel. So it is a composition of iron, carbon, manganese, and other metals. So they are used in railway lines, car bodies, car body guiders, it is rail line, car body guiders, and utensils. Then you have nichrome. Nichrome, it is a composition of nichrome and chromium. So it is used in providing resistance in electric heaters and ovens. So you have German silver. So it is a composed of copper, zinc, and nickel. So it is used in making coins. It is used in making coins. It is used in making coins. So it is used in making coins. So those are some of the alloys that we make from solid mixture. So this solid, they are in a position to melt. They're in a position to melt to form